So happy morning, guys. Today we can have a look over the salt analysis of class 12. So you know that salt combines of an acid radical and basic radical, right? The salt consists of an acid radical which is called as an anion and basic radical which called as a cation, right? So let us take NaOH. The NaOH consists of Na plus and Cl minus. Right. So this let us see part by part. First, we can go for acid radical. So this acid radical can be classified into three parts. That is dilute H2SO4 group, concentrated sulfuric acid group, barium chloride group. So this barium chloride group, in sense, this is a group reagent. The barium chloride is a group reagent here, and here a concentrated sulfuric acid is a group reagent, and here dilute sulfuric acid is a group reagent. Right. So what are the anions for you for the salt analysis in plus 2. So these are the anions, that is carbonate, nitrite, sulfite, unsulfide, chlorine, bromine, iodine halogens, acetate, nitrate, and oxalate, phosphate and sulfate. So these are the anions you are having for your plus 2, right? So let us start from the basic, that is BaCl2, right? BaCl2 group. We are having sulfate and sulfite here. So barium chloride in the sense we can easily do that. Take a test tube, add some salt, some water, and put some barium chloride solution in that. You will get white precipitate if sulfate or sulfite is present, right? Along with that white precipitate, add some dilute HCl. If the precipitate does not dissolve, it shows the presence of sulfate ion. If the precipitate dissolve, it shows the presence of sulfate ion. 90% sulfite will not be there for you, so sulfate you can take, right? So that is the third group. Third group, we are having only two anions, sulfate and sulfite. So barium chloride group. So we have to add barium chloride. So salt plus water plus barium chloride, it gives a white precipitate. You have to add dilute HCl with that white precipitate. If it dissolves, it is sulfite. If it does not dissolve, it is sulfate ion. Right. So next we can go for the concentrated sulfuric acid group. Concentrated sulfuric acid group. What are the anions present here? Chlorine, bromine, iodine, nitrate, and acetate ion. Right. So this is concentrated sulfuric acid group. Salt plus water plus freshly prepared ferrous sulfate solution. Freshly prepared ferrous sulfate solutions in the sense you have to add a pinch of ferrous sulfate salt into the test tube and add some water. So that is a freshly prepared ferrous sulfate solution. Add with salt and water, and concentrated sulfuric acid should be added along the walls, not directly. Should be added along the walls so that you can see the brown ring at the junction of the layer. So if there is a brown ring formed in your test tube, it shows the presence of nitrate ion. And if there is no brown ring and the solution turns or the precipitate turns black in color, so that shows the presence of nitrite ion. That shows the presence of nitrate ion. So salt plus water plus ferrous sulfate solution plus concentrated H2SO4. So we can identify between the nitrate and the nitrite ion, right? Nitrite ion will be in the dilute sulfuric acid group. Here itself we can identify. So nitrate means there will be brown ring. If it is a black precipitate, it is called as a nitrite ion, right? Now, next, what are the things present in this thing apart from the nitrate we had completed? So you have to go for acetate and halogens, right? Okay, here. So salt plus water plus concentrated sulfuric acid plus silver nitrate. So if you add silver nitrate, if it gives white precipitate, that is called a chlorine. If it gives yellow precipitate, that is called as iodine. If it gives pale yellow precipitate, that is called as a bromine, right? So halogens we can identify in one test. What is that? Salt plus water. It's a common thing for all reactions. Concentrated sulfuric acid plus silver nitrate. So we call it as a silver nitrate test, right? Concentrated sulfuric acid plus silver nitrate. If it gives white color, it is called chlorine. If it gives yellow color, it is called as iodine. If it gives pale yellow color, it is called as bromine, right? So what are the things over? So chlorine, bromine, iodine over, nitrate over. Then we have to go for acetate, acetyl group, right? So we have to prepare a lead acetate paper. Lead acetate paper is nothing but take a pinch of lead acetate salt, dissolve it in water, and tear a piece of filter paper like this and dip the filter paper in the lead acetate solution. Then it is called as a lead acetate paper. Put that lead acetate paper in a test tube and add salt plus dilute H2SO4. Salt plus dilute H2SO4. If the paper turns black, it shows the presence of sulfide, and if brisk appearances comes, it shows the presence of carbonate, CO3, 2 minus, right? And here, for acetyl group, take a watch glass, add salt plus NaOH plus water and smell it. If there is a smell of acetic acid or vinegar, it shows the presence of acetyl group. So salt plus NaOH plus water, smell it. And if you have the vinegar smell, it shows the presence of acetyl group, right? So I think these things are over. That is barium chloride group, concentrated sulfuric acid group, and dilute H2SO group. And you have to understand, guys, there are much more tests over there. For nitrate, there is another test. For confirmatory test is also there. This is for identification only, right? Identification short tricks. So you have to go for the regular procedures to go for the confirmatory test. Right. So now the acid radical we had identified. Now we have to go for the basic radical. Is that clear? Acid radical is it over or not? Now shall we go for the basic radical? Yes, these are the basic radicals we are having for you. So group 0 is ammonia, group 1 is copper, group 1 is lead, group 2 is copper, and group 3 is ferrous, ferric, and aluminum. Group 4 is cobalt, manganese, nickel, and zinc. Group 5 is barium, calcium, strontium, and group 6 is magnesium, right? So I already told you that if group 0 comes, if group 0 is present in your salt, you will write all the test up to magnesium, and after that you have to write the test of group 0, and then you have to confirm the presence of ammonium. Right. Rest of all you can stop whatever it may be. If group 3 is there, you can stop writing here itself. You need not to write group 4, 5, and 6, etc. So for group 0 and group 6, you have to write the entire procedure. Right. Now coming to the point here. So first group is lead and second group is copper. Second group is copper in the sense it's a colored sort. There is no possibility of getting copper, but there is a slight percentage of possibility to get the copper in the group 2. And group 3, you can clearly understand that the ferrous and ferric are colored salts. Right, the ferrous and ferric are almost colored salts. We can identify by the color itself. So that there is no possibility of getting ferrous and ferric. So there is high possibility of getting aluminum here. And here in the cobalt, manganese, nickel, and zinc, there is a high possibility of getting zinc than the remaining. And here in the barium, calcium, strontium, we can get all the all. And magnesium, there is a possibility of getting magnesium, right? So we can go for the test. So these are the group things. Cations. Now, so as usual, we know that salt contains a cation and anion. Cation means we know that basic radical, anion means we know that acidic radical. So first group contains of uh, zero group. Let us come from the zero. Ammonium. First group contains of lead and mercury. Mercury will not be for you, so need not to worry about that. Second group will consisting of lead, copper, arsenic, and cadmium. So, being lead is identified in the first group itself, no need to worry about the second group. So, copper is there is possibility, arsenic and cadmium will not be for you. And third group, we are having Fe3 plus and An3 plus. As I told you, ferrous is colored. So, there is high possibility of getting aluminum in third group. And fourth group, there is nickel, zinc, manganese, and cobalt. Right, manganese and cobalt, there is less possibility. So, nickel and zinc, we can get. Nickel is also, we are having very, very less possibility. So, fourth group, we can get zinc. And fifth group, barium, calcium, strontium. These three also are highly possible. And sixth group, sodium and magnesium. Magnesium, there is a possibility. Sodium, it's not. We will not give sodium for plus 2 level. Right. Next. So what we have to do, we have to add first thing, original solution. Original solutions, what do you mean by original solution? Salt plus water is called as the original solution. Right. We have to add ammonium hydroxide to that. Original solution plus ammonium hydroxide. What happens if there is a blue precipitate? It shows the presence of copper. White precipitate shows the presence of arsenic. So white precipitate will not be for you. If blue precipitate is there, it shows the presence of copper. Before that, salt original solution plus dilute HCl. If you got the white precipitate, it shows the presence of lead. That is the first group. And here this is the second group, right? And next, salt original solution, salt plus water plus ammonium hydroxide plus potassium ferrocyanate. Potassium ferrocyanate. If you get the bluish white precipitate, if we can say that is a zinc. If you get the deep blue coloration, we can say that is the presence of iron, ferrous. Right. Here again coming back to the group separation here. Is iron is in the third group and zinc is in the fourth group. Right. So if you add NH4OH plus potassium ferrocyanate, there is a bluish white. Now it shows the presence of fourth group zinc, and there is a deep blue color. Now it shows the presence of third group iron. There is no possibility here for the presence of iron. So original solution plus ammonium hydroxide plus potassium hexacyanoferrate. If it gives bluish white precipitate, it shows the presence of zinc. Then original solution plus ammonium hydroxide plus dimethyl glyoxide. You can search this one in your lab, you will get it, right? If it gives a red precipitate, it shows the presence of nickel. There is very less possibility of the nickel salts. Anyhow, you have to know this one, right? Then original solution plus ammonium hydroxide plus 2 to 3 drops of blue litmus solution. If it gives a blue precipitate, it shows the presence of aluminium. It shows the presence of aluminium here. Okay, so what the things we are identified here? So we have identified copper, zinc, nickel, and aluminum. Right. Then uh, take the original solution, add some potassium dichromate with that. If it gives yellow precipitate, that is a confirmatory test for lead. So group separation, that is dilute HCl plus original solution. If it gives white precipitate, that is a group separation. Confirmatory test, original solution plus potassium dichromate. If it gives yellow precipitate, it shows the presence of lead or barium. So both the thing, potassium dichromate plus original solution is a reagent. This we can identify by group separation, right? So lead is in the first group and barium is in the fifth group. So if you got the precipitate in the first group, that is when adding the dilute HCl, if you got the precipitate, you can say, you can do the test and you can confirm that that is a lead. And if you got the precipitate in the fifth group, we can do the same test and we can confirm the presence of barium here. And the next test for lead is potassium iodide. Original solution plus lead. Original solution plus potassium iodide gives yellow precipitate. It shows the presence of lead, right? And original solution plus ammonium sulfate, not ammonium chloride or ammonium hydroxide, ammonium sulfate. Ammonium sulfate is not available, so you can add a pinch of salt, right? It gives white precipitate. It shows the presence of strontium, right? And original solution plus ammonium oxalate, it gives a white precipitate and it shows the presence of calcium, right? So just remember, potassium dichromate shall be used for the identification of lead as well as barium, and potassium iodide is used for lead, and ammonium sulfate is used for strontium, and ammonium oxalate is used for calcium. Original solution plus salt plus water plus HCl plus Nessler reagent. If you got the brown colored precipitate, it shows the presence of presence of ammonia.